And the process is we're interacting. The material needs to interact with the space. And basically works like that. It's applying nanomagnetism. So the ferromagnetic behavior of this gold in this specific size is unique. Actually, until 2012, the Japanese Radiation Institute acknowledged that the gold could behave as a ferromagnetic in the nanometric scale, because if you take the gold, you have jewelry in gold, that's good, that's nice, but that's not nanomagnetics, because the only way to get this response is if you reduce the size of the particle and you stabilize with other materials, other metals, and you keep it in that size. That's the reason we need to make films, round films, if we isolate the films with a recyclable plastic in order to keep the response of the gold nanoparticle in that level. And that's the way they call it right now, is ferromagnetic. For me, it's not the best word, but sometimes in science, when you have a response, you don't know how to name it, to label it. They call it in nanotechnology just a ferromagnetic behavior, but it's more than that, because all you know that in quantum is different. In electrodynamics, quantum electrodynamics is more than just the particle, it's the field, how it's behaving in the field. So what it's producing is a super coherent field that if you want to look, you are a scientist, you can look for Felix Bloch, a famous physicist in the early 1920s. He was talking about the domain walls in the magnetic orders. This is all related to this. In this fundamental level, the nano size is not the quantum size, but you can see reflex of the quantum phenomenon in the nanometric scale. And if you go below the nanoscale, all the behaviors are magical, are crazy, because are different. So one of my training in material science, I completed in Georgia Tech in 2015 in the IN Institute, was how the titanium behave and how the different copper behave. And for instance, all of you know that copper is conductive, moving electron, very good. We're using wires. But if you take the copper and reduce it, it will behave as an isolating material. So what you have as a behavior in macro scale, in the nanoscale, is not the same. It's not the same rule. It's different because it's set by the quantum fields that are interacting in this level. So the material basically is interacting, and I have here, this is the first time I bring from my bedroom for this event, because in the past I never did it. This is one of the powerful filters for high exposure to 5G, because we need it. We're exposed nowadays like never before. So the material is not sending negative ions to space. No, it's just interacting. The energy is interacting with the material and getting the response. So it's building up around the space. So this is a process that we are actually wiping out 2 billion interference in the whole electromagnetic spectrum from 0 Hertz to 300 gigahertz. So, but it's non-invasive, it's not putting a specific frequency in motion. So it's a multi-frequency filter, and you can work with your healing system with any frequency. The biological response that you get from the frequency you are using is going to be faster. Because what we are actually doing here is taking advantage of this super coherent field, and we're cleaning the space from this quantum noise. And we can measure the quantum noise. Very important remark that Dr. Ruby said the first day was, where is the evidence? Because we need to back our statements in evidence, not in hypothesis. And for instance, and I will move with this thought, if you place the disk in your bedroom, for instance, and you have your Wi-Fi router in the other bedroom or in the other room, you will be protected from what? You will be protected from the microwave that is coming from the far field exposure from the router. But if you walk and go to look something in your office, you will expose to the near field. It's low frequency radiation is still harming you. But if you move the disk, if you place the disk close to the router, you will interact with both, with low frequency and high frequency, with the near field and the far field response is going to be clear. So it matters where you place the material. It's very important. And in technical studies, what type of technical studies we have? We have studies on interference, SAR tests, a specific absorption rate. We basically shoot signals to our cell phones. If we look how it behaves, we prove that it's reducing 90% the peaks of the emission of the cell phone. Even we are not blocking the functionality of the device because we are cleaning the interference in the vicinity. The cell phone use less battery, so it will produce less bubbles. It's going to be a weaker bubble, and the bubble is going to be filtering out. We have studies in OTA tests. This is a summary. And also in laboratories, very, very professional laboratories, the same that telecoms use, and Wi-Fi propagation pattern, and RF network analysis. And we run EMF assessment of near-field exposure to figure out this. And we have biophysical studies in HRV and brain and tinnitus. We conduct specific brain studies using people suffering from tinnitus, and I will explain more about it. Brain and cognitive decline, sleep quality, and by far the biofields and the stress response and a lot of things I will share with you what we're doing with BioWell change everything. Actually, with BioWell studies, we have a protocol that we use, and we need to use the full spectrum of the features that we can do with the GDV camera. I mean, we do it for people and we do it for the spaces, for the environments. So we have a protocol to do assessment in specific spaces. So we run specific scans with Sputnik and also with the water sensor. We use 2 GDV devices to do this type of test simultaneously and see it, how it's behaving in water, what is the signal we're getting from the Sputnik. And we work with the people that have suffering from EMF sensitivity. We have a set of protocol, 10 types of different scans that we can conduct in them, and we can figure out how sensitive they are, how they're responding, and different other things.